This is the site from where you can download RASP. Most people are able to open it. Okay. Download it. Yeah. How? Yeah, it should be there. You might have seen that. There should be a RAR file. You have to just unzip. You should install that. Yeah. So when you go to the, I hope all of you have downloaded RASP. So when you go to the RASP folder, RASP main, you will see that this is the application, and whenever you download RASP, some of the example datasets are also downloaded with it. So all those example datasets are in this sample folder. To open it, you will see there are 3 folders: Psychotria, Ruby-AC, and Simulation. So we will work with the Psychotria dataset.
Hey, you want to first show them just debug?
Oh, yeah, I'll show them.
Debug, and then they can go straight to.
Yeah. So you have to click on the application. You should be able to see a window like this.
Both it has apparently.
Yeah. So unlike BioGeographic's, RASP is pretty easy to use. Okay. It's the GUI version of the software, and it does everything that BioGeographs does. Okay. All the authors say that it uses BioGeographs to come up with the likelihood of the different models. So you can do everything you do with BioGeographs with RASP.
Apparently.
Yeah, we don't know how to work.
If it works, it's great because people who don't code can still.
No, but that's what we still want to compare the results. Only then I'll be sure that it's actually doing the job.
So I have never used RASP. I have just figured it out how to do it only 2 or 3 days back for the workshop. So we'll work with the. So first, you need actually basically you need minimum 2 files to run RASP. One is your tree file, time calibrated phylogeny. So remember that we run tree annotator after when the beast run was over. So you got lots of trees sampled from the stationary phase, and you summarized all those trees with tree annotator to get a consensus tree. So we have to use that tree file for RASP. Okay. So if you go to the Psychotria folder, you can see that there is a condensed. There is a file named condensed. It is a TRE file. So basically, these authors, they run beast and they have summarized all the trees and they are calling it a condensed tree. So the output of tree annotator should be the input for RASP. So we have to upload our phylogeny to RASP. So for uploading your file, you have to go to this option, file, and you have to go to load trees. Okay, you guys are following? Then you have to go to load trees, more format. Okay, just click on that option. So as I have opened this file previously, so it is, for me it is directly showing the Psychotria folder. So you guys have to navigate to the Psychotria folder and choose the condensed tree. Okay, .tri file. And click on open. So all of you are with me? Yeah, outside. You can navigate to the Psychotria folder. Yeah, condensed.
People are still looking for it.
Okay, just navigate to the Psychotria. Condensed. You have to open the condensed.
Drag and drop both. Because let's not show you the.
So is day 5 practical, sir?
Maybe you have expected so where are you expecting the So all of you open this file.
Yeah, this contains the file, where is it?
It is in the cyclopia folder. Sample for data.
Day 5?
Not day 5, it's in phylogeny software.
It is in phylogeny software.
That's what I did.
You should ask me.
To make a quest.
Okay. So now we have successfully uploaded your time calibrated phylogeny to RASP. So now you have to upload a file, that is the geographic distribution file. So while running biology of years, all of you have seen that we prepared a geographic distribution file in Node tab. But that file won't work with RASP. So for RASP, you have to create your geographic distribution file separately in Excel. Okay. So just go back to the Cyclopia folder, and there should be a file named distribution. It is a CSV file, okay, comma delimited file. So you should open that distribution file. So if you want to run your data set in RASP, you should code the distribution in this way. There are 3 columns. So first column belongs to the serial number, and then you have the taxa. And then on the next of the column there are ranges A, B, C, and D. So you have to remember an important point, that is in biogeography you can code your biogeographic areas with any of the letters you want. K, G, E, F, X, Y, Z, it don't matter. But in RASP you have to code your areas with continuous letters. Okay. It should be A, B, C, D if you have 4 areas. Or it should be E, F. I mean, it has to follow the order. If you are giving random values, it won't work. So you should be preparing your distribution file like this and save it in the CSV format. Okay? All of you got it? Okay. Now,
So what's happening here? What latest? Getting excited.
I'm looking for a job.
okay. So now you again go to file. We'll now load the distribution file in RASP. And click on load stakes. Distributions in bracket, that option. So again you should navigate to the Cyclopia folder. As I have opened this file previously, so it is automatically choosing that folder. And choose the distribution file and click on open.
Each month,
If RASP has successfully read your distribution file, you should see something like this.
It says it cannot access it.
So like, whole bunch of decisions are pending on me. Do I move? This is if I don't move, going to work every day is a huge, ordeal. And I've been at home to do work. There are no active projects. We were just talking yesterday about how terrible it is that, they don't move. I mean, like verbally they'll say, okay, it's extended. But
So all of you are ready to open it? Any of you are facing any problem? So he has faced.
Yeah.
Just try. So his RASP is not reading the CSV file.
Huh?
For him, RASP is not reading the CSV file. Yeah.
What about this one? The thing is also not working.
He won't.
Oh. No.
No correct distribution. I think RASP does not.
No, not yours.
So very hard to please. We're trying to please I have not printed out and I need to put that. I'll send it to you. That will be
What is it?
Okay, this one.
We need to come up with
No, I have to get it.
I mean, it's not able to access it.
They're supposed to give it to you or something. Tiny little birds and yeah. That's how they were.
Okay, there was one big article yesterday about Sheshadri in.
The factory.
Huh? Deccan, yes. The canopy work.
Yeah.
I tried to read it. I didn't. He's like climbing up the rope and all. He's really savvy with the media. Every other month he's something or the other. Hey, forget it. Let's move on.
So for him,
Huh.
we are going to troubleshoot the error.
And I just closed it.
No, I think you
Do a demo.
So that distribution file was open. So you have kept that file open in Excel.
Oh, the file was open in Excel.
Yeah.
Yeah.
Oh.
Let me close that.
Okay.
Your errors.
Well, if you want to look at it positively, at least it tells you there's an error.
Instead of saying dims 1 and 2.
No, instead of just going boom.
Yeah, that's true.
And you're like, what the hell? Why? Then if it tells you an error, you're like, okay. Some programs in the past that's what they would do, right?
Yes.
It's a glitch and it just goes off.
So all of you are in this step. Okay. So first we will try SGBA, running SGBA. So that is as Praveen told you, GMA of Geographic. Then we'll go on testing more complex models.
In fact, you can do it by hand. Whatever SD1 is done, you can do it by hand. It's so simple. SD1. Those rules you follow. That's about it.
Just trace back.
Yeah.
So here there's the fundamental fitting the matrices.
So you go to reconstruction. You press reconstruction,
But you have to do it.
and then you go to on trees.
So it will do it.
Okay.
This will have to do it.
And you choose the option statistical dispersal Mercarian analysis. That is SG. So it will come up with a dialog box.
You all got it?
What if on
You've
trees?
got to do it all there.
On trees is not working.
If you could always code it.
All of you are able to see this dialog box. Seems like you have not uploaded it. You have just uploaded the distribution.
This is open. Close the mic. Listen to that step.
Just try it.
These are interns, so we take it as yes. Yes, sir.
Think what are
She has a book. She's not able to unzip the install.
Basically, he forgot to upload the tree. He only uploaded the distribution file. Okay, so then move. Okay, so this is the dispersal matrix it is showing. So if you want to allow dispersal between different areas, or if you don't want to allow, then you can accommodate it here. We'll just run it with the default settings. Okay. So you just click on OK, and you can see that max areas at each node is set at 4. That is there are 4 areas, 4 geographical areas for distribution, A, B, C, and D. And maximum number of areas it can occupy at any node is 4. It can't be greater than the number of areas you have provided. It can be less than that. So we'll click OK.
Again, you have to think about your data set. If you think that max area cannot be 4, it can be max 3. So, change it accordingly.
Yeah, so it has started running. All of you did this. Look, it took only 1 or 2 seconds.
What about adjacency? How that does not, Viva is not there.
Viva,
Only max area. Only max area. And areas are
No.
no, you can specify all this.
Huh?
And dispersal. That's all.
Yeah.
No areas are now at least
No, areas allowed is there.
Yeah.
A, B, C, D, and all that. And max area.
You get all those options in Geographic in RASP as well. I'll show you later.
No, so now it's already running, right?
It is done.
It's done.
Yeah.
Okay. No, my point was, in case of Viva, the only 2 things you have to keep in mind is areas allowed and max area.
Yeah,
That's it.
Yeah, that's it.
But that's the one that you clicked was areas allowed, not dispersal.
So you can say range constraints.
That's areas allowed.
Yeah, that is.
Yeah.
And also you can
Areas allowed is sort of like a proxy for your dispersal.
Yeah. Actually, in some of these areas can be excluded. Isn't it?
Yeah, like
yeah, based on your knowledge of the system, you can
Yeah.
exclude some areas. If I exclude B, D, this combination,
Yeah.
then it will exclude all the combinations with B and D.
Yeah. So you need to think about this a little bit. Some of the areas are probably not possible. If you have 2 widely separated islands, for most nodes, those 2 species distributed in those 2 islands is not possible. So you have to unclick whichever that area is. Right?
So I'll run it again by changing the max area that each. So now I have set max area that each node to 2. And of course you can change, upgrade this number of threads for a faster analysis.
Max area is 2.
2, correct?
You can just play around with these values. Yeah, so it is done. So once your analysis is done, it will show here in this console analysis area. So now we want to visualize our results. Okay. So for visualizing your result and output, you have to go to Graphic and click on the option Tree View. So all of you are able to get it. Got it? So this is the ASDIVA reconstruction of ancestral states. Go to graphic language history, and you will get the legends here that which color codes for which area. And also you can change the layout of the tree. You can go to view, this option view, and you can click on this option. Like BioGeoBase, RASP does not show you that which is the most likely state at each node. It's showing a probability. So you can go to view and click on this option, display MLS in center. MLS is the most likely state. Then it will show that which is the most likely state at each node. This is yeah. So here it is not showing the probability. So it is showing the most likely state. So
it's basically saying that the ancestral area of the whole group was in A,
yeah.
right? And then you have the dispersal to B.
Yeah. So one
Down
down
here, yeah. Dispersal to B, and then dispersal from here to C,
yeah.
and then from C to B again, and then to D, and so on. So these are different islands that emerge at different. This is a Hawaiian island.
Yeah.
Yeah. So you can save both the versions of the tree with most likely state and also with the pie charts. So if you want to save this tree in this format, you have to go to File and Export Tree. Sorry, Export Graphic. You have to go to Export Tree.
Anyway, that they'll figure it out. Let's not worry.
X-axis is the
Time.
Yeah, it is time calibrated tree. So it is showing the time.
That's in millions of years.
Yeah. Yeah.
This is
So the oldest island is 5.5 million years old. So the route distribution should be the oldest island, right? It can't be a younger island.
So I can view the result in a picture format.
I think A is the oldest island, no?
This is the same psychotry or
Yeah.
or psychotry or
So you can
data.
compare this one with the biology.
Yeah. A is basically K in the other.
So this was ASDIVA, and all of you know that it uses parsimony.
Yeah.
And now we will do the likelihood version. Okay. Oh, one thing, you have saved your tree. Suppose if you want to save the legend, or if you want to publish your tree, you will also have to supply the legend. So you have to go to File, Export Graphic, and then you will get the option Export Legend. And also you can save your legend as a picture. Okay. So we are done with ASDIVA. Now we will see that you have two windows. Just get back to this window in RASP.
Everyone,
Just get
can we get back?
Our analysis window.
Close the graph.
Yeah, you can close the ASDIVA.
Sorry. SDO window.
Now we are going to do what we did in biology of this. Okay. So RASP also offers 6 models for range evolution like biology of this, the DIVA-like, DEC, and May. So this DIVA-like is a another version of that SDGA, but it does not use parsimony. It uses a likelihood framework and the J variant of all the models. So you have total 6 models. So you have to go to reconstruction, click on it, and you have to then click on model test. So if you go to model test, you will see an option that compare models using biology of layers. You have to click on this option. Okay, compare models using biology of layers. So again, you are getting this window. So this is the areas among the different areas you can allow for dispersal. Also, you can exclude it.
Okay, keep the same as you were.
Oh, okay. And you can see that there is an option, and then it test plus J models. So if you keep this thing unchecked, it is going to run area like deck and diva like, not the J variants of the model. And if you check this option test plus J models, then it is going to run plus J variants of all the models, and total 6 models. And if you want to time stratify your analysis, you can do it here. But right now we are not going to do it. And we are going to run it with all the default options. For SDGA,
What about dispersal multipliers? It's not there. So it's just like adjacency matrix and time set stratify.
no dispersal multipliers are there. If you time stratify your analysis, then you will get all these options. Look, you can get to code the area adjacency areas allowed, dispersal multipliers, and distance matrix. Basically, distance and dispersal multipliers are almost same.
Oh.
But without time stratifying, you should be able to code dispersal multipliers. No? I mean,
Yeah.
I mean, why should it assume equal dispersal if it isn't a time stratified?
Yeah, I think you can also code dispersal multipliers or unstratified analysis.
How do you do that?
Okay.
Oh,
Oh. So in this way you can do this. I don't know on which basis it is taking the time stratification. But
you said so on the right column is where you set your time strata.
oh,
So the number of matrices on the left correspond to the number of time periods you
so you
have.
can manually put
Yeah,
a value.
you can edit that.
And you can also modify the dispersal multiplier
Yes.
for that time.
Yeah. So I think in that drop down menu, when you choose dispersal multiplier, then you are editing the dispersal multiplier. Then you
Yeah.
save and apply, then you can do the areas allowed.
Yeah.
I mean,
So in this way you can also provide an area adjacency.
yeah,
Right.
yeah.
And then you can just save and apply.
So you can do it even without the time structure.
Yeah.
Yeah.
So you can do basically everything you do with biology of layers.
Yeah, that's what I'm saying.
Yeah.
But I want to compare the two results.
Yeah. But yeah, that is not how it will make it harder because he'll have to sit there and code all the matrices to look exactly like how the other one looks. I mean, we can try it later.
Yeah, that's what.
Yeah.
If you have time, maybe for our let's do bigger. The people.
I'm trying.
Yeah. This is actually. Should I proceed? Oh yeah, please. Okay, everyone's here. With the time stratification and all that, you guys can figure it out. We'll just keep it simple for now.
Yeah, so basically you can go to this time stratified option, choose one matrix and define different values for that time period. So for now we are going to run it with the default settings. And the max areas is set to 2. And I'm going to click OK. All of you with me?
Before we have set the max areas to 4.
Huh?
No, that also we change.
No, after that we change it to 2.
Huh.
It is not a problem. So now click on OK. So it is showing that it is running value of LS.
So this is deck and deck plus J?
Yeah.
Well, it's actually on 6.
Oh, all 6.
You should see how fast it is. And in few seconds. Look, it is done. So remember how much time GeoGraphic was taking? Now it is just done in a few seconds. So now we are going to check the results. So you go to graphics and then tree view.
It also tells you which model is better.
Yeah, I mean we can see it in a better version. I'm going to show up. So this is your result. Okay. So RASP has run your data set through all the models and class J variant of all the models and reconstructed the ancestral states. So in this panel here on the left side, you see that all the models are listed here. Take results. Then there is take plus J result. Then there is diva-like result and diva-like plus J. After that, Bay-Area-like, then Bay-Area-like plus J. So if you want to visualize the results of a particular model, you can just simply click it on. So previously by default it was chosen day. I'm now choosing day plus J. Look, the reconstructions are different. I'm just going to display the most likely state in the center. So you see how the probabilities are changing. You're going to take a day plus J. Then I'm going to choose diva-like. And if you want to get all these values for a particular node, you can just double click on the node. So it will show the values and what happened at that node. I mean probability of different states. Like we have given maximum 2 states, A and B. So here for node 32, it is showing the probability of A and B. A has a probability of 95.5826 always, and B has this 2.647. So A is the most likely state for this node. Okay. So in this way you can check the ancestral area reconstruction under all the models. And now you can click on Information tab. So RASP calculates all these things for you and how many nodes dispersal and variance has happened. So I'm going to choose Bake plus J and then go to Information. So here in this part you can see that highlight event. There are 4 options: dispersal, vicariance, extinction, global. So if you choose one option, suppose I am going to choose vicariance, then RASP is going to show that under this ancestral area reconstruction, under Day plus J, where vicariance happened.
So that's good.
Wow, look, I have chosen vicariance, yeah, pretty cool. So at these 5 nodes, vicariance has happened. Then I'm going to uncheck vicariance and check.
As you have noticed, we are learning along with you.
So now I have clicked on dispersal. At this node, dispersal has happened, and also if you click on each node, you can figure out dispersal happened from where to where. Okay. Now I'm going to choose extinction.
Oh, ancestral area and child node. So I think the dispersal happened from ancestral area
Area to child.
But there are 2 of these. Anyway, we'll figure it out.
So where is the extinction happening?
Here.
So it means to say that some level of extinction is happening there.
Yeah.
At that.
Yeah, because it's a day here.
There's one region that's missing from here. The tip nodes.
Yeah.
I think one region is missing, so it's probably accounting for local extinction in that region. So there is that yellow, there is red, there is purple. That's all. But there's no blue with the B mode. So B, I think that's. Oh.
I think local extinction has happened at E.
But how is it saying that this, all these areas are affected? Yeah.
That is also based on the dispersal process. Yeah, that matrix. Yeah.
So we will actually run this in run these data sets.
So, you are saying something?
No, I was just telling them that we'll run the data set on BioGeoBears and RASP in future and figure out if this is doing a good job or not, right? And so keep in touch, we'll let you know.
If it is doing a better job, it is a relief for us because it is pretty complicated. Oh, so here you can click on the global info. So it will show you that at every node, dispersal happened from where to where. So look, it is showing information for every node. Suppose that node 22, you can see event group. It is showing dispersal happened from C, B to C, and then
There's one dispersal event and one bicarious event. Right?
yeah.
So even matrix.
Which is can you click which is the node 22? Can you click here? And then, on node 22. Yeah. Can you click?
Okay.
The remove the only the topology. Show pi and
It was showing all these nodes, right?
yeah, it was. What if you undo everything?
Yeah.
Yeah.
Okay, I'm just going to click on this.
Okay, wait. Let's look at that one. So now that's node number 32, huh?
Yeah.
Oh, this is dispersal, and then vicarious section.
That's how you do.
No, that's ready.
Simple.
Yeah.
It's okay. I mean, look at this. This is what node 27, huh?
Node 27.
Okay, that one. So from A to A to AB. So this is this A?
So blue was A.
Okay, and purple is B.
And purple was AB together.
Oh,
Purple
okay.
is A. Yeah.
So B is added, and then there's again vicariance between A and B.
Yeah, for a bicarious.
Yeah.
It's pretty cool.
How do you compare the different models?
Yeah, I'm going to show that. So in this way, you can play around and you can specifically figure out that what are the event matrix at each node. Okay.
And you can also it also does a likelihood. I mean, it does a test, right, as to which model.
Yeah, I'm going to show it. And like I have shown before, that you can also set the result for a particular tree. You can format this tree with the view option and set the image and the legends here. So now we are going to see the results of the statistical test RASP has done on all these models. Which model feeds the data better? Okay. And also comparison between the plus J and without that J variant, comparison of different models like J and J plus J. So what does RASP do? It does comparison among all the 6 models. Okay. It gives you a likelihood score and it also compares between the plus J variant of each model without J and with J. And it does a likelihood ratio test to come up with it. With plus J, it is having a better likelihood.
It does a ratio test, likelihood ratio test.
Yeah, it does everything.
So it does it use AIC values.
It does likelihood ratio test and both tests.
Oh, okay.
So if you want to visualize the results of this test, just go to supplement. Okay. But here it is pretty basic. You can't figure out that what is what. So we have to save this result in Excel. So just go to no, it will again become messy. So just go to File and go to save info and save supplemental information. So I'm just going to save this file. My desktop. So all of you have saved it. Did all of you save it? Okay. So now you minimize RASP, come out of it, and open the supplementary information. So it will come up with this dialog box. Do you want to open it anyway? You have to press yes. And then you come up with this cool results. Everything ready for you. All of you with me? Yes? So the first table, you will see that it has tested all the models. Okay. Then text plus J, then diva-like plus J, varial-like plus J. It is also showing you how to choose the best model. I mean, what more you can ask for? Use the highest archaic weight to select the best model. Okay? And you see the archaic weights for all the models. And clearly you can see that DEC plus J has the highest archaic weight. And also it shows the likelihood values for all the models. DEC plus J has the best likelihood, and it also shows the number of parameters. And the estimated value for all the parameters. D for dispersal rate, E is for extinction, and J is jump dispersal. So you can see that without J, only in DEC, diva-like and Bay Area-like, the value of J is 0 because we are not allowing jump dispersal in those models. And in the second table, it is doing a likelihood ratio test between the J variant of all the models. I mean, with J and without J. So just come to this column. Your null hypothesis is DEC model, and alternate hypothesis is DEC plus J. And it is investigating which one of this model fits the data better. Thus adding the J parameter improves your likelihood score significantly. And you can see that, yeah, it does.
What's the p value?
Yeah.
Go for all of it.
It's here. P value is here.
Oh yeah.
Very low for all fields.
Look how low this figure is. That means that the plus J models are much better than
How to interpret the key stats?
well,
Key stats. Before the key value.
all these things. These things, I think, number of parameters.
No,
No, the one after that.
Key stats.
These
Oh, these are. I am not. I don't know about this.
But I'm just wondering, is it a surprise, right? From the other table, we can see that the J parameter actually adds a huge value.
Yeah.
So it doesn't really prove the case for testing it this way, rather sort of supports our criticism of using
Yeah.
it to compare between ones.
No, but this is this is not good, right?
Yeah, it's
This is
not
not
good.
good. Yeah.
Yeah.
So what one should basically do, at least what the critics have pointed out, is that you can compare, Diva, DEC, Diva, Bay Area, and DEC, or Diva plus J, Bay Area plus J, and DEC plus J. Those comparisons are fine, but you should not compare, DEC versus DEC plus J. Because invariably, when you add the J parameter, you get a much better likelihood score. So that's what the critics have pointed out. So I would just compare these and that, but not across, DEC and DEC plus J or Diva and Diva plus J.
So Geographic came out in 2030, I think. And after that, whenever people do model testing in Geographic, it always prefers the plus J variant of every model over without J. The plus J variant always gets extra likelihood because it allows for jump dispersal. Whenever you are invoking this founder event speciation, then it better explains your data. So
And often it is unrealistic, right? I mean, it might be a biogeographic region with no islands at all.
yeah,
And even there, it will prefer plus J.
yeah. So in 2018, a criticism came out against biogeography. These are the authors of Untitled and Salmon. So they, yeah. So they address this issue. They are saying that there is something wrong with biogeography. It never chooses the, without J model. It always shows that with plus J, it is better.
The criticism, the PDF for it is in the reading material in your Spotify.
So the author of Geographic came up with this funny challenge, unlimited BM challenge, and he said that if anyone can find a data set for which Geographic supports take over take plus Z, then sponsor unlimited beer for that person. And it feels like that only this year he came up with a data set of California's butterflies, where Geographic supported the take scenario over take plus Z. And now he is writing a criticism of the criticism made by Uri and Salman.
Okay, on that note, shall we wrap it up? Any questions?
So that's it, based on these statistics.
So I think IQ3, you guys figured it out. How long will you take?
Should it be too long? Almost as the partition file is the most important.
Can you do it in like 10 minutes? Come, let me download it.
So that was the same with RASP. Now you just play around and figure out what will be the best setting for your data.
Okay, which version is it?
Okay.
Okay. Which version?
What is the reason?
So even this is late, he's also the resource person, last minute resource person. That's why I quickly introduce him.
Just search IQ3.
You know, you just give a demo, man.
That is easy to follow.
Like you. So the online version is better or the one that you download, that's probably.
Which one should they download? The COVID release or the stable release?
Always stable. They are always in beta testing.
What is this COVID?
Why is it COVID?
That is a special version.
It's a command line based program.
It's not a computer.
Huh?
It's not a geographic.
No, apparently. Oh yeah, you're right. I mean, everything is like you have to type in.
Like Mr. Beast.
Yeah. Yeah. But I'm sure once you get used to it, like Mr. Base nowadays is so convenient. Once you get used to the command line thing, I think.
But does it do anything like extra?
Not really. The only thing is model selection. So all the classified goods have been discontinued. The support is terminated. So they are just.
And it also has this ultra fast scrap.
No, I'm asking, does it do anything different than the web server?
Oh,
Because the web server is pretty easy to use.
Not sure.
yeah, web server is quite easy to use.
I think maybe there are some need for.
Nothing. Just go to the web server.
The web server is
You just like click, there's your sheet.
Click there.
you just need to upload your data set as a FASTA file
That's it.
and then click a bunch of options.
Yeah.
You want to
It will give you the model, the best model.
that will
that
go
we
for
have.
Vivek Bachchan.
I mean, what are the.
Yeah.
So yeah, just like for XML we define partitions, here also we'll define partitions for same being sequence that we previously used. So the primate file.
15.
By default, it has some models. You can just
Change the part names as well for the candidate.
So all of you are getting this window.
No, he's just demoing it.
So how to come to this window?
So you must have a example.next file inside the folder for IQ3. So I'm just making the nexus file. You made a similar file for RASP as well, or even for partition pointer. So I'm just replicating, but IQ3 requires a slightly different format from the file.
You can put the partition file also no, in the website.
Yeah.
Yeah, you can add it in the same format, make it as a text file.
So I have just been working faster, but it's already changed this into a WhatsApp. So
Can we alter?
To change it to fast, yes.
see,
I mean,
I use C. Need to work.
You can also just change it from it. I mean, export it as a faster file.
this it takes like 15 takes faster.
Yeah. You could also
You just invoke IQ3. So here I'm in my terminal calling IQ3. Dash S is where
but his alignment is faster.
so dash S is the parameter for calling in your file. So I've called the file that I want to analyze. So there are multiple options for you to define whether your different branches should have differential rates. So for ensuring that your every partition has different rates, for making them separate rates, you use dash SPP and you will pass on your partition file like this. For testing the models, it uses something called model finder plus. So dash M is command for performing the model search, and immediately after the model search, we also want
Model of sequence evolution.
sequence evolution. And you can test the model separately, as well as you can run the model test and immediately ask it to begin the research. So this is a combined option for this. You can also use test merge only or test new merge for just finding the model.
Where do you find all these?
So if you just type IQ, so
Hey, can you increase the size of, because I don't know if people can see. Oh, yeah.
so
Oh.
that's the total for native coding sometimes is not good. So if you have a multi-core system, you can also ask it to define what's the maximum number of cores that it has and let it decide how many cores it has. So it essentially portions of the analysis. And obviously if you want to test we run to run for bootstrap. So dash DB for running ultra-fast bootstrap. I don't know what they actually do with ultra-fast, but it runs really quick. So ideally the resist 1000 is good enough. We will put this 1000. And if you want to set multiple runs, you can also put multiple runs. So for that would run multiple. So I have some whether in my partition.
I don't know how I figured that out. So I'm like, oh, that's not fake. And I think
So see, there's an error here. So it's right out an error saying there's some problem with your next system. Always a good. The ending should go with the head of the command. So it starts looking for, so it looks for best partition scheme for the data as well as the small for the partition scheme.
It's not exactly like.
Gives a log file, right? The best one for every partition.
It's just the question of knowing those commands and then preparing your input files
And just-
appropriately.
Yeah.
And then
And with the online tool, the Python, you don't have to remember the commands. You just have to go and just bring your options there. It's only about preparing the input files.
What happened to you?
I quickly, like, the standalone thing on the,
So getting the details of what all options there are. I don't know why it's so. So if you just press -h, help command for activity, so it shows you what all are the options available for you. Model selection, defining strategies, ancestral activities. Type mode.
looks like some ways.
I don't know, the offline one is quite easy. It started pretty complicated.
Someday it will stop the whole bunch of what I would do.
It's looking at the various montages.
It's taking a very long time.
Okay, it will not take this long.
But actually the output file for the web version also it looks like it has all this.
Yeah, yeah.
I mean, for people who are not used to that level of,
But you might be able to do a lot more with this version. And the web version might not have many options.
I don't know, I have never used a web version.
Okay, to get it.
Yeah, can this then have it up there? Yeah. So,
I don't know why it's I don't
great. Great, thanks, yeah. So let's, when you get a chance, just compare the web version with the machine version. Okay, people, we need to have a good photo. We don't have any natural dark. No, but we have a camera.